Okay, welcome back. So we've already figured out how to do moles to moles, volume to volume, particles to particles, and mass to mass. But what if things are all switched up? So you're going to skip down here and you're going to see that we have a grams, we have a mass, and then we're looking for volume. So this is what we call a mixed stoichiometry problem. So if I go back, this is a map. So technically you can go anywhere you want following the roads, doing what you got to do. So I was given mass and I need volume. So you could see that I could go mass to moles, moles to volume, volume to volume. But I could also do mass to moles to moles of the other thing, moles to volume of the other thing. So it doesn't really matter. And technically you could go woot doot 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 doot, but that's crazy. I generally like to go through moles and through the center, but it's up to you. You could do whatever you got to do. You're going to need a conversion factor somewhere. So use your mole map. This is the same reaction as the last question, so I'm just going to quickly write that down again. And it was 6O2 yields 6 CO2 and 6H2O, and that's an L, and 566. All right. If this mass okay, so that is what we are given. That's our no. What do I seek? I seek carbon dioxide. So I'm going to go grams to moles to volume. That's what I'm going to do. So I'm going to go grams to moles. I figured out on the last slide the GFM is 180. So 180 grams per mole. So 15,550 divided by 180 equals 86, and don't round here, just keep it on your calculator, whatever. This is going to be moles of glucose. Now I'm going to use my conversion factor. I seek carbon dioxide, so that's a 6. I know glucose, which has a 1 for a coefficient, so I'll multiply by 6. 518.3, repeating, whatever, and this is moles of carbon dioxide. Now I need to go to volume, so I'm going to multiply by the, what do you call it? Molar volume. And so I would get 11610.6 repeating. And that would be liters. That's a lot. So let's figure out sig figs. Because I've got 4 sig figs, so 11610, and that's it. Liters of CO2. So with a mixed problem, you just get there. You just follow your mole map. Okay, not too bad. All right, theoretical yield versus actual yield. In theory, all my students will always be doing their work. They will always be studying. They will never copy. They will never cheat. They will always ask questions when they have questions. They will do their homework on time, perfectly, every time. That's in theory. In actuality, my students wait till the last minute. They miss deadlines. They cheat. They copy. They make mistakes. They get frustrated. They don't ask for help. So that's actuality. Theory is not always actuality. So theoretical yield is what you expect should be produced or used in a chemical reaction because of math. But guess what? Then you can actually do it in the lab and you see it's not the same. It's the true amount. And so there's a formula for percent yield, which is actual over theoretical times 100. This is not in the reference tables. A general idea. It's sort of like percent error, but a little bit different. If 300 liters of methane is burned to warm a home, what mass of water is produced? Okay, so CH4 burned CO2 plus H2O. All right, so let's see. Balance. I'll try that. Balance. Does that look good? 2 carbons both sides, 4 hydrogens both sides, 4 oxygens both sides. Okay, good. Calculate the expected mass of water to be produced. Okay, so we started with 300 liters of methane, so that's our no. And this is what we're looking for, our seek. So we need to go from liters to grams, mass. So I'm going to divide by 22.4. And 300 divided by 22.4. And I'm going to get 13.39, whatever. This is going to be moles of this. Now, I seek water. I know carbon or methane. So there it is, times 2. 26.78, whatever. And this is moles of water. And then to go from moles to mass, you're going to multiply by the gram formula mass, which is water, 18. So I'm going to get 482.14, blah, blah, blah. If you're doing sig figs, which you should, I guess, is 3. So let's just say 482 grams of water. That's what I expect to form when I do the math. However, when I actually burn 300 liters, I only got 420 grams. Oops. Because it's real life. It's what happened. So the formula is actual over theoretical times 100. My actual yield was 420 grams. My theoretical yield was 482 times 100. So 87.1% yield. And you can ask yourself, is that a good yield or not? Well, I don't know. It's pretty good. All right. We're going to stop there. And if you have any questions, please reach out.